Welcome you all to the video lecture on signals in system. Today we are going to discuss about the problems under classification of systems. So classification of systems, we have 5 types of classification. One is linear or non-linear, another one is static or dynamic. Static is also called as memoryless, and then dynamic is also called as memory. And then another classification is causal and then non-causal, time invariant or time variant, stable or unstable. We are going to discuss about all these classification for this problem, that is y of t is equal to x of t minus 5 plus x of 3 minus t. First of all, the linearity. What do you mean by linearity? So linearity means it obeys superposition theorem, or I can say that the output due to weighted sum of input is equal to weighted sum of output. So I can say that always the linear system obeys the superposition theorem, and then I can say that output due to weighted sum of input is equal to weighted sum of output. So let us discuss about the problem for that. So first step for linearity, let me discuss the linearity first. For linearity, first step is we need to find out output due to weighted sum of input. Output due to weighted sum of input. So output due to weighted sum of input means, again, suppose for example if I am considering the input as x1 and x2, okay, and then I need to x1 and x2, okay, and I am going to multiply x1 by a and x2 by b, okay, and then I am going to add. This is nothing but weighted, okay, weighted sum of inputs, okay. We have 2 inputs and it has been multiplied by each and every input is multiplied by some scalar, okay. So weighted sum of input, okay, and I am going to find out the output of this, okay. So what is the output for this? I am going to find out, okay. That is the transformation, some transformation I am going to apply, okay. So how I am going to find out the output? When I am going to apply the transformation. When I apply transformation, I will be getting the output y. So system is one which will process some input signal, okay. So the process, I can say that transformation, some transformation it is going to apply on your input signal and you are going to get the output signal. Output signal is generally denoted by y, input signal is denoted by x, okay. So for the problem, first step I have to find out output due to weighted sum of input. For that, wherever I have y, okay, wherever I have y, I have to replace it by a y1 of t plus b y2 of t. So y of t should be replaced by a y1 of t plus b y2 of t. Similarly, wherever I have x, I have to replace it by a x1 of t plus b x2 of t, okay. This is my first step. So when coming to the problem, what I have y of t in the left hand side. So I need to replace it as a y1 of t plus b y2 of t. And then next I have x of t minus 5. Instead of x, I have x of t minus 5. No issues. This I have to write for 2 times with the suffix 1 and suffix 2, and then I have to multiply x1 by a and x2 by b. So I have to replace this as a x1 of t minus 5 plus b x2 of t minus 5. And then similarly the next term, how I can replace? A x1 of 3 minus t plus b x2 of 3 minus t, okay. So this is the first equation, and then next is I have to find out weighted sum of outputs. Okay, weighted sum of output. Step 2 is I need to find out weighted sum of outputs. So, how you have to find out means, okay, first write the given equation as it is, okay, and replace y by y1, x by x1, okay. First replace the given equation as it is, replace y by y1, x by x1. So, I have x1 of t minus 5 and x1 of 3 minus t. And then multiply all the terms here by a. So, multiply both left hand side and right hand side by a, this equation by a. So, I will get a y1 of t, a x1 of t minus 5, a x1 of 3 minus t. So, this is my second equation. Write your equation as it is with the suffix 1, okay, y by y1, x by x1. Multiply all the terms by a. The third step, again write the equation as it is with the suffix 2, y by y2, x by x2. So, I have 2 terms in x. So, x of t minus 5 will become x2 of t minus 5, x of 3 minus t will become x2 of 3 minus 2, and multiply this equation by b. So, multiply each and every terms by b and consider this as third equation, okay. And finally, find out 2 plus 3. Finally, find out 2 plus 3. So, a y1 of t plus b y2 of t is equal to a x1 of t minus 5 plus a x1 of 3 minus t plus b x2 of t minus 5 plus b x2 of 3 minus t. This is my fourth equation. Now check whether first equation is equal to fourth equation. So, whenever first equation is equal to fourth equation, the system is said to be linear. If first equation is not equal to fourth equation, then the system is said to be non-linear. Okay, I am going to check each and every term. Here a y1 of t, here also a y1 of t. Here b y2 of t, here also b y2 of t. No issues on your left hand side, all are available. Right hand side, a x1 of t minus 5 available, b x2 of t minus 5 available, a x1 of 3 minus 2 available, b x2 of 3 minus 2 available. So, 1 is equal to 4. The system is said to be the linear system. Whenever first equation is not equal to 4, then I can say it is non-linear. But the given system y of t, x of t minus 5 plus x of 3 minus t, since first equation equal to fourth equation, meaning that output due to weighted sum of input is equal to weighted sum of output. Therefore, the given system is said to be the linear system. Okay, and then let me move on to the next classification. So, what is your next classification? We need to find out whether it is static or dynamic. Okay. So, what is your expression? Y of t is equal to x of t minus 5 plus x of 3 minus t. So, to determine whether it is static is also called as memoryless. So, memoryless in the sense it will depend upon only the present situation. Okay, it will depend upon only the present input, present values. Dynamic means memory system. So, it depends upon all the things. Okay, so it depends upon past also, it depends upon future also. Okay, so whenever the system depends upon past or future, then the system is said to be dynamic system. Okay. So for example, you are listening the class now, you are able to understand now at the present situation, then it is said to be memoryless, that is static. And if you are able to remember the previous lecture also, then it is said to be past. And if you are able to concentrate now and then in future, if you are able to do the homework and all with the present situation, whatever I am giving the input, then it is said to be future values. Okay. So a system which depends upon only the present values is said to be static or memoryless system. A system which depends upon past or future inputs, then it is said to be the dynamic system, which is also called as memory system. Okay. So here for the problems, it is very simple. Just substitute three values, one present value, one past value, one future value. Present value means just take t is equal to 0. Okay, past value means any value, -1, -2, like that, any negative value you can take. Okay, and then future value means you can take any future value like 1, 2 or 3. Okay, so for all the past values you should have the same answer, and similarly for all the present value and future value you need to find out. So when I substitute t is equal to -1, I have y of -1 is equal to x of -1 minus 5 is nothing but -6, x of 3 minus of -1 is nothing but x of 4, and then t is equal to 0, present value, one present value I am substituting, y of 0, x of 0 minus 5 is -5, and then x plus x of 3 minus 0 is nothing but 3, and then t is equal to 1, substitute t is equal to 1. So x of 1 minus 5 is nothing but -4, x of 3 minus 1 is nothing but 2. Okay. So substitute one positive value, one negative value, one 0 value. Okay. So negative means past input you are giving, present input, future input you are giving. And what you have to do now, you have to check the functional value of x only. Okay. Only the functional value of x you need to consider. No need to consider, for example, if you have any multiplication factor 2 or some cos function cos, all those things no need to substitute. Okay. Only we need to substitute the t values whichever it is there in the input functional value as well as input functional value and then output functional value. Okay. So now check your values. Here it is -1, here it is -6. Whether -6 is lesser or greater when compared to -1. I am substituting -1. So whether -6 is lesser value or higher value. It is lesser value. Lesser value means it is called past value. Okay, it depends upon past input. And then here it is minus, here it is 4. So 4 is greater than -1. So output is depending upon future value. Okay, and then similarly 0. When comparing 0 and -5, this value is past. Okay, when comparing 0 and 3, this value is future, higher value. Okay, and I am having 1 here, I am having -4 which is lesser value, so it is past. And then I am having 1 here, it is 2, it is said to be the future. So I need to check whether the after substitution whether I am getting present input alone. Present alone means it is static. If suppose any one value becomes past or one value becomes future, then it is said to be dynamic system. Okay. So here I have to write the statement that since the output depends upon past and future values, whenever one value is itself future, one value is itself past, then it is said to be dynamic system. It is not present, it is not present input alone. Okay, so it is dynamic system. Okay, since output depends upon past and future values, okay, it is dynamic system. Okay, and then the next classification is causal or non-causal. Okay, so static means memoryless, which depends upon present. Dynamic means memory, which is depends upon past and future. The next classification here itself I used to discuss causal or non-causal. Causal means it depends upon present and past values, past inputs, And then non-causal means if any one becomes future, then it is said to be non-causal. Okay, the next classification, causal means it depends upon present and past, non-causal means it depends upon future. Since again for this problem, okay, so no need to again substitute and see, here itself we can write the statement, since it depends upon future value, future it comes, it is said to be non-causal. Okay, since the output depends upon future values, okay, depends upon future values, it is called non-causal. It is called non-causal. It is called non-causal system. Okay. So only present means static. If suppose I get any one past or one future, then it is said to be dynamic. And then if only present and past alone is said to be causal. If any one value becomes future, it is said to be non-causal. The next classification is time variant or invariant. Again let us consider the same problem, x of t minus 5 plus x of 3 minus t. Okay. So time invariant or variant. Okay. So time invariant means there should be a proper relationship between the input and output with respect to time. Okay. So here how we can find out whether it is time invariant or variant. Okay. For that what I need to do? I have to find out two things. Step 1, output due to input delayed by t seconds. Okay. Step 1, output due to input delayed by capital T seconds. Okay. So we need to find out the output whenever the input is delayed by t seconds. Okay. So wherever I have input, I should just insert a delay of time t. Okay. So minus t put, and then x of 3 minus t, and again one more minus t. Okay. So this again you can represent it as y of t comma t, or sometimes you can also represent it as y of t minus t. Okay. It is your wish. Okay. So this is my first equation. What you have to do, wherever I have input, with the input functional value I have to delay it by capital T seconds. So put 1 minus capital T inside the functional value of input. Okay. And then second step, output delayed by t second. Output delayed by t second. So what you have to do means, output itself delayed by t seconds means wherever you have small t, you have to replace it by t minus capital T. Okay. So wherever you have small t, you should replace it by t minus capital T. So considering your given equation, here y of t, so t will be replaced by t minus capital T, and then x of, here again I have t, it should be replaced by t minus capital T minus 5, and then plus x of 3 minus of, here again one t I have, so t will be replaced by t minus capital T. So within the braces you have to write t minus capital T. So it becomes now y of t minus capital T becomes x of t minus capital T minus 5 plus x of 3 minus t, minus into minus will become plus. Okay. And then I will be getting like this. So this is my second equation. So I have to compare the first equation and second equation. If my first equation is equal to second equation, then the system is said to be time invariant. Then the system is said to be time invariant. But here 1 is not equal to 2. Why? Because here I have t minus 5 minus t, here I have t minus 5. Anyway both are same terms. Okay. But when compared to here 3 minus t minus t, here 3 minus t plus capital T. So 1 is not equal to 2. 1 is not equal to 2, hence the system is said to be time variant system. Hence the system is said to be time variant system. Okay. Since the equation 1 is not equal to 2, the system is said to be time variant system. If both the equations are equal, then it is said to be time invariant. If it is not equal, then it is said to be time variant system. So the last classification is stable or unstable. Stable or unstable, it is very easy. So what you have to do means, you have two things. One is the Bibo stability criterion. Another one is when h of t is given, you have to find out whether it is absolutely integrable or not. Okay, so here they have given y of t. So we need to find out whether this is satisfying the Bibo stability criterion or not. Bibo is bounded input. Okay, bounded input, bounded output. What do you mean by bounded input? Whenever my input is finite, bounded means my input is finite. Okay, and whenever my input is finite, okay, both the inputs are finite, I should determine whether my output is finite or not, whether my output is bounded or not. Okay, so here anyway, whenever this input is finite, okay, then whenever this input is finite, I am considering, and this input is also finite, okay, then definitely my y of t also becomes finite. Okay, so bounded, if I have bounded input, okay, and I am getting bounded output, then the system is said to be stable. So here if x of t is bounded, okay, if x of t is bounded, here in this problem definitely y of t is also bounded, I of t is also bounded. Hence this system is said to be stable. Hence this system is said to be stable. Sometimes there may be a chance that even though my x of t is finite, because of other multiplication terms, okay, y of t becomes infinite. In that case the system is said to be unstable. Okay, here there is no any other multiplication terms or any other functions apart from your input, no other functions is there. So this becomes finite, this becomes finite, definitely y of t also becomes finite. Therefore the given system is said to be a stable system. Okay, thank you students, thank you for watching.